Lord God, thank you so much for giving us another day to study and prepare for a good life in the future. Thank you for giving us the chance to continue learning amidst the pandemic, which caused a lot of changes in our lives. Bless our parents who work hard to support us. Bless our teachers who are doing their best to inspire and guide us, especially in these trying times. Bless our country and the people who continue fighting to stop the pandemic. Lord, fill us with your wisdom, knowledge, and understanding. Give us good memory so that we might understand and remember what we are going to study now. These we pray in the name of Jesus Christ, our Lord. Amen.
Hello, good afternoon. So,
Afternoon po.
nasa na kayo iba? Okay. Anyway, recorded naman tong klase na rin kung malilate sila. Okay, may mga pumapasok. So, some reminders again. Keep your microphone silent unless you have to speak. Always turn on your camera before speaking or commenting. State your name. Speak in a normal tone and at a normal volume. And refrain from side conversations. So, ang klase natin ngayon is from 3 to 4. Okay, so 1 minute lang tayo dahil nga kayo ay 1 hour lang tayo, sorry. Dahil kayo ay AOL. Okay? So, kung napansin nyo, kung binuksan nyo na yung module 1 nyo, nakita nyo na hanggang module 3 yung laman noon. So, dahil nga nakalagay doon ay 9 hours, so tatlo siya, i-divide natin siya sa 3 meetings. Okay? So, module 1 muna yung i-discuss natin ngayon. So, bagong lahat, ayan, panoorin muna natin yung some applications ng matrices. Kasi ang module 1 natin is about matrices. So, mas maganda kung magkakaroon kayo ng idea kung ano ba yung matrices, ano yung application niya. Okay?
This video is sponsored by Dashlane. Circuits and electronics, image processing, computer graphics, quantum mechanics, the Google PageRank algorithm, any kind of network, other stuff. These are the kinds of things where matrices are used and extremely important for understanding or analyzing different systems. And although I can't discuss everything in one video, this should give you some insight into the applications of matrices beyond what an introductory course might include. Now, in the beginning, matrices can be one of the most boring subjects we learn in math. Maybe not for everyone, but at least that's how it was for me. Transposition works. Real simple, you just sum the corresponding entries, and you have your answer. Then multiplying a matrix by a single number is as simple as multiplying every entry by that value. But when it comes to matrix multiplication, we do this weird row by column dot product multiplication, which some teachers just give no context to. So yeah, this isn't the kind of stuff that makes you want to major in matrix math anytime soon. I mean, you might learn more in high school, but...
And guys, so yun yung pag-aaralan natin ngayon, yung addition and multiplication din.
Overall, a lot of it just isn't that exciting. However, I promise matrices are used way more than you probably think. But the first thing we need to realize is that matrices do things to vectors. Don't take this as a definition
because
it's obviously...
Matrices daw do things to vectors. Ano ba yung vectors? Okay? So sa math, pag sinabi nyo kasing vectors, siya yung isang quantity na mayroong direction. Okay? May magnitude and direction. So mamaya malalaman nyo kung ano ba yung vectors.
not, but we do need to see what happens when we multiply a matrix by a vector. For example, a vector that starts at the origin and ends at 1, 1 can be written in matrix form as shown, x component on the top and y component on the bottom. And when you multiply by a 2 by 2 matrix like this, through the multiplication rules we get a new vector out, in this case of 1, 3. So we put a vector in, and the matrix scaled and rotated it to get a new vector out.
Ayan, nakita nyo, di ba? So, halimbawa daw, yung isang vector, yung 1, 1, kasi di ba pag paano kayo, mag-graph kayo, so yun yung isang vector. Kasi pag sinabi nyo kasing vector, guys, ano lang siya, isang column o isang row. Okay? So ito, in this case, isang column lang siya. 1, 1. Isang column. So vector siya. Ngayon, kapag pre-process natin siya sa isang matrix, ang kinalabasan niya ay, ay isa pang matrix din. So, ganun yung pagpaprocess ng vector sa matrix.
This is what I mean by the matrix doing things to the vector. And in this case, different inputs will be rotated and scaled differently, which we'll see in a sec. Now, some matrices are much simpler, like this one here just rotates. Put a vector in, aka multiply by the matrix, and out will come the same vector rotated 90 degrees counterclockwise. This matrix, on the other hand, will just scale. Any vector that goes in comes out twice as long. But most 2 by 2 matrices like this one we were analyzing aren't as simple. Different input vectors, I'll just put a few here as an example, get scaled and rotated differently. However, the transformations are all...
So, pag sabi daw, pag iba-ibang vectors, pag sinabi nyo kasing vectors, ngayon kanina may given na mga coordinates. Okay? So, iba-iba naman kasing coordinates sa graph. Tapos, mapapansin nyo yung graph nila, iba-iba din. At iba-iba din sila ng transformation. Dito kasi sa video guys, yung kulay blue dyan, yun yung mga given na vectors. Tapos yung red, yun yung nagiging transformation niya. Bakit iba-iba yung transformation? Siyempre, iba-iba sila mag-react doon sa matrices. Pag pre-process kasi ng matrices, mag-iiba yung direction nila. Okay?
all linear, as in any vector on the same line as one of those inputs map to a vector on the same line as the corresponding outputs. These linear transformations are why we called the first in-depth class on matrices linear algebra. Anyways, I'm going to redo those
Ayan, nakita nyo na yung first application ng matrices, yung matatagpuan nga sa linear algebra. Okay? Kasi dito makikita nyo rin kung paano ba ginagamit yung matrices sa pagkukompute ng mga or pagsusolve ng mga linear algebra equations.
Transformations once more, but this time pay attention to this vector here. You'll notice it's the only one that is just scaled. It doesn't rotate at all. And this would happen to any...
So guys, sabi niya, yung kulay blue daw na ito, yung isang kulay blue na vector, yung pinakamalaking graph, siya daw yung isang vector na hindi daw nagro-rotate. Yung ibang vector kasi nagro-rotate siya. Tingnan natin bakit hindi siya nagro-rotate.
Any vector on that same line because of what we just saw. Any vector that is only scaled by a matrix is called an eigenvector of that matrix.
Ayan. So pag yung isang vector daw, o yung isang graph, okay, sa Cartesian plane, o yung isang coordinates, ay hindi siya nagro-rotate. Okay, yung graph niya hindi nagro-rotate. Pero ang ginagawa lang daw ng isang matrix sa kanya ay ini-scale up niya lang. Ibig sabihin, pinapahaba niya lang. Okay, pero hindi siya nagro-rotate. Nandun din siya sa course niya. Ibig sabihin, kung ano yung direction niya, nandun lang siya. So, ang tawag daw sa kanya na vector na yun, itong eigenvector. Okay?
And how much the vector is scaled by, or 2 in this case, since the length doubled, is known as the eigenvalue.
Ayan, yung
I'm not going to go through
eigenvalue.
how to solve for these, but the vocabulary will come up later. Now, the last thing to mention is that the first application of matrices we typically learn is how they help us solve systems of equations. The coefficients can go into a matrix, the variables go into another, and the outputs go here.
And guys, dito na makikita nyo yung isang way ng pagsusolve nito nga linear algebra. Mag-solve kayo ng equations. Isang way to para malaman nyo yung mga solutions ng dalawang given linear algebra equations. Okay?
Notice I'm using the same matrix as the one from the last slide, by the way. Using the rules of matrix multiplication, you can see that this and this are the exact same. So really what this is asking is which input vector does this matrix map to 1, 3?
And guys, kung mapapansin nyo, yung given sa taas is pareho lang dito sa pangalawa. Kasi dito, hinahanap din natin kung ano ba yung magiging value ng x and y na magsasatisfy doon sa mga coefficients. Pag sabi mo kasing coefficients, yun yung mga numerical value na naka-attach doon sa variables. Okay? At saka masasatisfy din niya yung mga constant doon naman sa kabilang side ng equation. Okay? By that, hahanapin natin yung solution niya. So, application pa rin to ng matrices, linear algebra.
Well, we already saw the answer to this. 1, 3 is this output. And the question of which vector will the matrix map to this involves us just doing the same transformations as before, but backwards to find the answer is 1, 1. That will be our solution. Going backwards is like applying an inverse matrix. And when the desired output...
And guys, yung para daw makuha yung solution, okay? So, going backward siya. So, kinuha niya yung inverse ng matrix. Okay? Kaya nga nakuha niya ditong solution ay 1 and 1. Kasi yun yung nagsasatisfy sa both equations.
Is the one being multiplied, then the vector it came from comes out. So x equals 1 and y equals 1 are the solutions. If we plug those in,
mamaya malalaman niyo kung paano kukunin yung inverse ng isang matrix
into the original equations, then both are satisfied, which is exactly what we were looking for. If you haven't seen 3 Blue, 1 Brown's Essence of Linear Algebra series, definitely check that out. This will all make a lot more sense. But here we're focused on applications, which we're going to get to now. Now, when systems of equations get more complex, all we have to do is expand our matrix, and we can analyze the system with as many variables as we want. The reason matrices are used in circuits and electronics, for example, is because these can be represented by linear equations in which all the voltages and currents are the unknown variables.
Yeah,
When the circuits get hectic,
sabi niya, yung isa daw application ng matrix ay sa mga circuits tsaka electronics kasi application din siya ng linear algebra doon. Kasi pag sinabi niyo kasi mga circuits tsaka electronics, masyadong malaki na o marami ng variables yung involved doon. So, i-expand lang yung matrix para ma-analyze yung mga components. Okay? So, yun nga isa niyang application.
Where we don't want to solve it by hand, we can just have a computer find an inverse matrix and we'll have our currents and voltages. But that's still not too exciting. So what about a system that continuously evolves over time? Like, for example, let's say there's a zombie outbreak at the local high school, pretty standard situation, and the place is quarantined so no one can go in or out, but the zombie infection is spreading. So we've got humans in the school and zombies, but no one is coming in or out, so the population remains the same. Now, let's say every hour, 20% of humans will turn into zombies. There is a cure for the disease, luckily. However, it's not always guaranteed to work. So we'll say that every hour, 10% of the zombies will return back to humans. At this moment, if there are 150 zombies and 150 humans, the question is, what is going to happen in the long run?
So guys, meron siya dito isang situation, another application ulit ng matrices, kung saan mape-predict natin kung ano yung mangyayari in the long run. Sabihin, kung makikita natin yung rate ng pagdagdag o pagbawas ng mga given na numbers. Halimbawa sa humans, 150, sa zombies naman 150 rin. Okay?
Now we're going to assume the changes happen in discrete intervals at the hour. So let's see what happens in the first hour. For the humans of the 150 starting out, 80% of them are going to stay human or not become infected. But we also have to add the 10% zombies that become cured and turn back to human. This leaves us with 135 humans after that first hour. It went down just a bit. For the new total of zombies, we would take the 20% of humans that got infected, plus the 90% of the 150 zombies that are not cured, giving us a total of course, 165 since these two numbers add together.
And guys, so dito daw, ginamitan dito ng isang equation, linear equation. Okay? Yung sa una, sa humans, nakagawa siya ng isang formula. Sa first hour daw, ayun, yung 80%, kasi nga, 100 minus 20 is 80.8 times yung 150 na population niya, plus, bakit siya 0.1 dito? Kasi nga, sabi, meron daw 10% na zombies na napapagaling, nagiging human. Kaya 0.1. Okay? So, tinimes lang sa 150 na kanina. Kaya ang lumabas na ngayon is 135. So, sinasabi niya lang na sa first hour daw, yan daw yung magiging quantity nung number ng humans, 135. Sa unang hour, sa zombies naman, ganun din yung ginawa. Okay? Sa first hour, tumaas siya from 150 naging 165. So bakit, ano ba yung maging application ng matrix sa ganito? Okay?
Together must remain 300. But we want to know what happens after a long time, so we got to keep going. After another hour, we write the same percentages, except now the number of humans is 135 instead of 150, and for the zombies we got 165 instead of 150. This outputs 125 for the humans and 175 for the zombies. So we seem to keep losing humans, but will this continue? Well, what we have here is some linear equations that can be represented as a matrix of those percentages which don't change. This is multiplied by the inputs h and z, or the current population of humans and zombies at any time, and all of this equals the populations after that given hour. This is...
And guys, nailagay na sa isang matrix, okay? Para ma-predict na nga yung hinahanap na mga values o yung solution.
Call the Markov matrix, by the way, since it's column sum to 1 and it has no negative values. But this is like what we just saw. The matrix we have is going to do stuff to, or scale and rotate, the input vector. The first input was 150, 150, the initial human and zombie populations. And after 1 hour or multiplication, it gets moved to 135, 165. But we have to keep going and apply another transformation, sending it to 125, 175, the populations we found after 2 hours. So as we keep applying these multiplications, the real question is, where does this vector go? Well, let me put a few vectors on the graph to show this, each representing populations which add to 300. If we do the matrix multiplication and look at the transformations, you'll notice this vector, or anything on this line, stays put, while everything else moves towards it. That vector is an eigenvector of our matrix. The associated eigenvalue is...
And guys, pinakita ulit yung eigenvector. Kasi pag inulit-ulit mo siya, halimbawa, sa first hour, second, third, fourth, lahat daw ng magiging value ng mga graph na yon ay papalapit daw dito sa tinatawag na eigenvector na naman yan. Kaya hindi siya nagbabago ng direction.
1 since it doesn't scale. And since that vector doesn't rotate or scale, it is the equilibrium of the system and therefore the answer to our question.
Ayun, so, si eigenvector daw yung equilibrium ng system na nagawa dito. Okay, so yun yung magiging solution.
After a long time, the populations will settle to numbers which lie on this line and add to 300, which would be 100 for the humans and 200 for the zombies. Any other population values will just move a little closer to these after each hour. If you put those values inside the equations from before, you'll see the output remains 100 and 200 for the humans and zombies respectively. Then if the percentages were to change, the question just comes down to what is the eigenvector of the new matrix? There may not be a zombie infestation anytime soon, but this kind of math could be used to analyze how a virus will spread throughout a population, for example. And one of my favorite applications of this is the Google PageRank algorithm, which involves Markov matrices and ranks websites by treating outgoing links as probabilities of transitioning from one site to another. For more on that, I have a dedicated video, which I'll link below. Now, moving on, here's a happy story. Not at all. On April 29th, 1992, a man named Reginald Denny was beaten nearly to death live on national TV, and this was just a completely innocent man who had done nothing wrong. You can see Reginald laying here, probably unconscious, after the attack. The attack itself can be seen here on YouTube, but in an attempt to not get age restricted like that video is, I'm only showing the portion right after. Now the backstory here is that April 29th, 92 was the first day of the Rodney King riots in Los Angeles. Reginald Denny was a truck driver whose route for the day involved going through an area where rioting was taking place, which he was not informed about. When he got there, he was stopped by rioters, dragged out of his truck, and that's when the beating took place.
And guys, so meron daw isang situation dati na kung saan may isang rider daw na binugbog ng mga nagrarayot na mga kabataan. So, ano yung application ng matrix dito? Malalaman dito kung sino ba yung bumugbog doon sa driver na yon sa pamamagitan ng matrix. So, tingnan nyo kung paano ginawa dito.
Now, identifying who assaulted Denny was not easy since the quality of the live footage wasn't amazing. But what helped law enforcement confidently identify one of the attackers was some advanced math. To understand how this was accomplished, we need to first look at what a digital image is, which when you look real closely is just made up of a bunch of pixels, each of a single color. Those colors can then be represented by some numerical value, which means like a square picture made up of 1,000,000 pixels, 1,000 along each edge, could be represented by a 1,000 by 1,000 matrix where the entries are the color values of each pixel. Working with black and white pictures is much easier though, because a black pixel can be represented with a 0 and a white can be a 1, let's say. We'll actually work with grayscale images here though, meaning anything in between 0 and 1 can exist, which will correspond to a different shade of gray. So when it comes to image processing and manipulation, whether it be blurring an image, detecting edges, sharpening an image, and so on, it all comes down to manipulating the pixels in a very specific way. To see an example, let's mathematically blur this image of the number 1. To do so, I'm going to make a 3x3 matrix where every entry is 1/9. This is known as a kernel in image processing, by the way. Then what?
So dito guys, i-blur niya yung image ng number 1. Okay? So isa siyang process sa graphics design guys, yung tinatawag na kernel processing, okay? Kasi i-blur niya. Kaya ito, i-multiply natin ngayon siya ng set ng matrix na to para mabawasan yung contrast niya. Baga mabiblurred siya.
What we're going to do is lay this kernel over our image matrix and multiply the individual entries in each square together, then add the results. In this case, it's just 1 times 1/9, 9 times, so the sum of all those is 1. Yes, this kernel is really just finding the average of the pixels inside it. From there, we're going to take that sum of 1 and set the center pixel to that color in the new image. It just so happened not to change. It's still 1 or white, but that won't always be the case. Now, you'll notice this grid on the right, where the blurred image will go, is the same size as the one on the left. To get the entire blurred image, we're just going to sweep that red section across the original one. When we slide it over once, all those pixels are still 1, so the average is also 1, and that's what this new pixel becomes. But after sliding over again, the kernel contains a black pixel, so we find the average of 8 ones and a 0, which is about 0.89. This corresponds to a very light shade of gray, which we will put in that middle square. After sweeping across the image,
and guys, so may nahagip siya na, pag may nahagip siya na kulay black, syempre i-scale din niya yon. At dahil nga minumultiply ito sa 1/9, liliit yung value niya. Kaya yan naging 0.89.
Mapping each new number to the blurred image, these will be the values. I know this method doesn't really account for the border, but for our purposes, we're just going to keep that white. Now I'll actually color in the pixels based on their values, and we get a blurred image of the number 1. Actually, this is extremely blurred, almost beyond recognition, but if we put an outline along the colored region, we can see the 1 is still kind of there. The reason this is so blurred is because we're only working with 100 pixels. But what the kernel did was kind of took this sharp edge in the original image between black and white and smoothed or averaged it so we get this fading from dark to light in the blurred image. The kernel we use represents a type of blur known as a box blur, and from Wikipedia, if you input a picture with many more pixels, then apply the blur, this is the output you get. But there are several other kernels that will all accomplish different things. A Gaussian blur also, of course, blurs the image, but it assigns more weight to the middle square, so dark pixels stay fairly dark and vice versa. There's a sharpened kernel, and there's edge detection
So may
kernels
iba't
which
ibang
search for sharp changes in
mga
color.
matrices, okay, na ginagamit
You'll
sa
notice that
graphics.
all the numbers in this kernel sum to
Pag-a-adjust ng ano
0.
nila.
So if we put it
Pag-a-adjust
over a
ng
section of
contrast.
an image where the same, multiplying by these numbers and adding the results would just yield 0 or a black pixel, which is why that corresponding area is black. The only sections that aren't are where we find sharp changes in color, aka an edge. As another example of edge detection, here's a poorly taken photograph of someone's arm, and by using edge detection algorithms, researchers were able to identify a region of some kind of birthmark or tattoo. Well, this is actually a zoomed in portion of this image, where those men can be seen beating Reginald Denny. Using image processing techniques similar to what we've seen, one company was able to determine that this mark was a rose tattoo affiliated with a certain gang in Los Angeles, and it was this that helped them eventually secure a conviction of one of the perpetrators of the attack.
So, pwedeng gamitin yung matrices,
now, all
guys,
this may not have involved
analyze
much matrix
yung
math
mga
like we saw
images.
earlier, but note I did simplify some things to avoid going into too much detail. And not only image processing, but computer graphics heavily use matrices. With these, what we can do is take geometric data and incorporate it into a coordinate system. We can then scale, rotate, reflect, shift images, and more through matrix manipulation. But things do get much more complicated. Like when you want to project a 3D image into a 2D plane, we can use matrix math to map the 3D points and find where they would appear on the flat screen.
Softwares natin, yung mga pan-drawing.
Not going to go into much more detail than that, but again, computer graphics are another very useful application of matrices. But for those wanting some real tangible results that come from matrix math, let's look at networks and graph theory. Graphs can represent a lot of things: people and who they're friends with, connections on a dating app, networks of cities and how they're connected, websites and how they link to each other, and so on. With small networks, it can be easy to intuitively understand what's going on. Like if I said here's a group of coworkers and connections represent mutual friendships, it wouldn't be hard to see like this is the most popular person and this is the least popular with only one friend. If you had to find how many mutual friends these two people have, no big deal. You can just count and see that's 3. But when the networks get more complex, we need mathematical tools to help us identify key things. This could be like which website should be ranked the highest on the web, which I mentioned earlier. It could be finding who's more likely to spread a disease in a college full of students, or which people involved in the 9/11 terrorist attacks were most critical to the operation and should be prioritized by law enforcement. Yes, they actually did this after 9/11, which I have discussed in a previous video. We need some mathematical techniques in these cases so we can find things that our eyes aren't always able to when the connections get this chaotic.
So yun guys, di natin tatapusin tong video na to. At least nagkaroon kayo ng pangunahing knowledge sa ilang applications ng advanced mathematics. Okay? Para magkaroon kayo ng interest dito sa subject natin. So punta na tayo ngayon sa module nyo, discuss natin. Okay? Kung na-download nyo, pwede nyo naman ako sundan. So buksan natin yung module. Okay, so ito nga module 1, matrices. Papansin nyo, nakalagay 9 hours. Sa schedule ninyo, 3 hours tayo, di ba, yung meeting natin. So, dahil 9 hours ito, tapos yung module na ito ay merong 3. So, hatiin natin yung hours na yon sa 3. Okay, so ito muna yung pag-aaral natin, yung module 1. Okay, so the introduction. Matrices and vectors which underlie linear algebra allows us to represent numbers of functions in an ordered and compact form. Kasi nga naman guys, yung matrices, naka-ordered siya. Kaya nga siya tinawag na ordered array of numbers. Okay? Naka-arrange. So matrices can hold enormous amount of data. Yan, sinabi ka na sa video. Maraming data siyang pwedeng ma-process. Think of a network of millions of computer connections in a form that can be wrapped by computers. How to solve systems of linear equations using matrices, yan, is also included in this chapter. So, malalaman natin yan. Then objectives. At the end of the chapter, students are expected to learn to define matrices, types of matrices, matrix addition as instruction, multiplication, the matrix transpose, the reduced row echelon form, elementary row operation, inverse of matrix, and lower and upper triangular matrices. Okay? So dito may pretest. So mamaya sa pretest nyo guys, sasagutin nyo lang to. Can you add a row and a column vector with different number of components? So pwede nyo bang sagutan? Ang isasagot nyo lang ay yes or no lang, okay? So sa ating Google Classroom, gagawa ko doon, pwede nyo nang sagutan, yung mga makakapagsagot. Okay, attach nyo na lang. Attach nyo na lang, sagutan nyo yung pretest. So, special class. Yes or no lang guys yung sagot. Buksan nyo yung nyo, Google Classroom. Okay? Nabuksan na ba? Yung pretest 1, i-attach nyo, i-comment nyo na lang din yung sagot nyo, guys. So, sa number 1, di ba sa classroom natin, may nakalagay na pretest 1. Click nyo lang, tapos i-comment nyo na lang yung sagot nyo. Okay? Diyan sa pretest. Ayan, yung unang question doon, can you add a row and a column vector with different numbers of components? So, yes or no lang. Next naman, with the same number of components, ay number 2. Tapos, 2 row vectors with the same number of components but different numbers of zeros. So, yes or no. And a vector and a scalar. Vector with 4 components and a 2x2 matrix. So, yes or no lang yung sagot. Pwedeng comment nyo na lang dun sa classroom natin. Okay? So, sige. Habang nag-discuss tayo, pwede nyo gawin yun. Okay? Punta tayo sa lesson proper, course methodology. So, matrices, which are rectangular arrays of numbers or functions, and vectors are the main tools of linear algebra. Okay? So, yun yung mga main tools natin sa linear algebra. Kasi nga, nilalagay natin dun yung mga components nung equation. Okay? To visualize them and to solve them more easily. Okay? So matrices are important because they let us express large amounts of data and functions in an organized and concise form. Okay? Furthermore, since matrices are single objects, we denote them by a single letters. Kasi pwede natin i-represent guys yung isang matrix ng single object. Halimbawa, parang set lang. Set A, parang ganun. Pero dito, matrix A, matrix B. So big letter or capital letter. All these features have made matrices and vectors very popular for expressing scientific and mathematical ideas. Okay, so gamit na gamit yung concept ng matrices. So matrices having just a single row or column is called vectors. Yun nga yung kanina, kapag makita kayo ng isang row lang, okay, o isang column lang na matrix, vector ang tawag sa kanya. Okay, so syempre, kapag isang row, ang tawag sa kanya ay row vector. Diba guys? Then kapag column naman, ang tawag sa kanya ay column vector. Okay, so the goal of the indexing of entries was to uniquely identify the position of an element within a matrix. So ano ba yung goal nung pag-aayos natin ng mga variables sa loob ng matrix? Okay? So para malaman natin yung position ng mga elements. Kasi yung mga variable na nilalagay natin doon, yun na rin yung magsisilbing elements. Okay? So sabi pa dito, one index suffices for vectors. Ibig sabihin, yung isang pagkakaayos ng mga elements sa isang matrix, nagde-describe na yun ng direction ng vectors. Okay? Whether they are row or column vectors. So let us first take a look at matrices before we formalize our discussion. So itong mga example nito guys, makikita natin yung unang example, meron siyang 3 columns, 2 rows. Okay? So the first matrix has 2 rows, yan, which are horizontal. Siyempre, pag rows, horizontal. Okay? So furthermore, it has 3 columns, which are vertical. So the second and third matrices are square matrices. So pag, ano naman yung tinatawag na square matrices? So pag sinabi mo square matrices, meron siyang equal number of columns and rows. So the entries of the second matrix have 2 indices, significant their location within the matrix. Okay, so dahil nga meron siyang 2 indices, ibig sabihin, dalawang pagkakaayos, okay? So na-specify niya ngayon yung location. Location ng mga, location ng mga elements sa matrix, okay? So the first index is the number of the row and the second is the number of the column. So saan natin makikita yun? Mapapansin niyo dito guys, sa example na to, A sub 1, 1, tapos A sub 1, 2, A sub 1, 3. So yung mga suffixes na yon, okay, sub, mga numbers sa ilalim ng letter, pinapakita lang noon kung saan siya nakaposition sa isang matrix. Halimbawa, itong A sub 2, 2. Kaya 2, 2 kasi nasa pangalawang row siya, tsaka nasa pangalawang column siya. Okay? So, ganoon lang din sa iba. Ayan. Sabi dito, matrices having just a single row are called vectors. Nga. So, thus, the fourth matrix, ito, vectors to, yung pang-apat, vector to, kasi, ano siya, row vector, tapos yung panghuli naman ay column vector. So, tandaan nyo yun, ha? So, punta na tayo ngayon sa addition and scalar multiplication of matrices and vectors. So, what makes matrices and vectors really useful and particularly suitable for computers is the fact that we can calculate with them almost as easily as with numbers. So, indeed, we now introduce rules for addition and scalar multiplication. So, ganito lang guys ang pag-multiply. So, yan, the product of any matrix in any scalar is written as C, small letter C, big letter A. Ibig sabihin yan, yan yung multiplication by a number. Okay? And is the matrix obtained by multiplying each entry of A by C. So, gato na yun guys. So, ito yung example natin, yung matrix A. So, square matrix siya kasi meron siyang equal number of row and column. So, pag minultiply down natin, or yung unang niya palang ginawa is pinag-plus niya. So, pag pinag-plus yung A tsaka B, ganito lang. Napansin nyo, bakit siya naging 10? Kasi pinag-plus lang yung magkakaparehong location. So, 5 plus 5, kaya naging 10. Tapos, ito bakit naging negative 9? Kasi pinag-plus lang yung negative 4 and negative 5. Okay? So on and so forth. Ganun lang, pag mag-addition kayo, ay pagpa-plus nyo lang yung parehong location. Mga elements na nasa parehong location. Ito naman, ito, nag-multiply ng number or ng constant sa isang matrix lang yung multiplication. Si number 2, minultiply kayo 5, kaya 10. Ayan, minultiply nyo sa lahat, kayo negative 4, kaya naging negative 8. Okay? So, i-distribute lang pag multiplication. O pareho lang kung si 3 naman, multiply mo kay matrix B. Kaya napansin nyo guys, di ba 3? 3 times 5, yan, naging 15. Okay? Kasi 3 yung pang-multiply natin eh. So, lahat ng nandun sa loob ng matrix, minumultiply lang kung meron siyang multiplier na constant. Okay? Or isang number. Ito naman, paano naman kapag kukunin yung difference? So, madali lang din kasi nga nakuha na natin yung twice nung matrix A. Di ba na 2 times A na natin siya? Okay? So, nakuha na rin natin yung thrice, yung 3 times matrix B. So, ipagsasubtract lang natin yung magkakaparehong location. So, dito, kay 2A, yung una niyang location ay 10. Tapos yung corresponding location naman niya kay 3B ay 15. So, 10 minus 15, kaya nakita nyo dito, is negative 5. Okay, so ganun lang guys. Halimbawa ulit kay 2A, dito sa may bandang baba, 22 siya, minus yung same location, corresponding location kay yung kanina kay 3B. So, negative 15. So, imbes na minus, magiging plus. So, 22 plus 15 is equal to 37. Maliwanag ba, guys? Pag may tanong kayo, magtanong lang kayo, ha. I-unmute nyo na lang yung microphone nyo, then magtanong. Punta na tayo ngayon sa matrix multiplication. So, dito magmumultiply na tayo ng isang matrix sa sumunod na matrix. Okay? So, it means that one multiplies matrices by matrices. Its definition is standard but it looks artificial. So, sa definition niya, madali lang pero meron tayong rule kasi dito na susundin. So, thus, you have to study matrix. So, kailangan pag-aralan ito ng carefully, then multiply a few matrices together for practice until you understand how to do it. Okay, so ito yung isang example. Ito yung pinaka-template niya, guys. Okay? Napansin nyo, si matrix A, na meron siyang column, MN, okay? Column tsaka row. Tapos, kay B naman, ayan din. Kasi i-multiply natin yung row ni A sa column naman ni B para makuha si C. Okay? Ang tawag dito, guys, is multiplication of rows into columns. So, kung ano yung unang given, kung ano yung rows niya, okay, per row yun i-multiply natin yung per row niya doon sa per column naman ng pangalawang matrix. Okay? So, ito yung unang example niya. Ayan, ito daw si matrix A. Tapos, ito naman si matrix B. Okay? So, ang unang row ni matrix A ay 3, negative 2. So, i-multiply natin si 3, negative 2, the first row, doon naman sa column ni matrix B, which is 2 and 3. So, isa-isayin natin yung kaya napansin nyo dito, sa solution, ayan, 3 times 2. Okay? Tapos, plus, pagpa-plus lang natin kasi nga dalawang elements yon. So, plus, ayun, negative 2 times yung corresponding naman na column. Okay? Kasi row by column eh. Kaya, nung pinag-plus, 3 times 2, 6, plus negative 2 times 3, negative 6, so naging 0. Kaya napapansin nyo guys, yung una ditong element ay 0. Okay? Tapos pareho lang din yung gagawin doon sa iba pang elements. Nag-gets? Ay. Ngayon, pagbabalik ta rin naman natin, yung B naman yung mauna. So, pag nauna naman yung B, syempre, ang i-consider natin, yung row naman ni B. Tapos, pangalawa naman si A, ang i-consider natin kay A, ay yung column naman niya. Kaya ito, bakit siya naging negative 4? Kasi nga, ang first row ni B ay 2 and 5. Okay? So, multiply lang natin by element. Kaya nakita nyo dito sa solution, 2 times positive 3 plus, ay ano yung row niya? Ay yung column niya, negative 2. Tapos, minumultiply natin siya doon sa row ni B, which is 5. Row element ni B, which is 5. So, ganoon lang guys. Kung ano yung mauna, yung i-consider nyo doon ay yung row. Tapos, yung susunod naman, ay i-consider nyo ay yung column. Okay? May tanong ba doon sa multiplication? Madali lang, di ba? Ang matrix. So, punta tayo dito, may word problem. Okay? So, an avid reader wants to keep track on how many different types of books and magazines that he reads. Okay? On June, July, and August, he reads fiction and non-fiction books and magazines, both in paper copies and online. Find the total number of books and magazines that he reads per each type. So, dito, may isang reader daw, pinapahanap sa atin kung ilan yung total copies, okay, na binabasa niya ng mga books per each type. Okay, kaya nakita nyo sa first matrix natin ito. So, magkadugtong to guys yung nasa baba. Hindi siya nasama eh. Diba kay June, yung number of fiction daw niya, naka-paper ay 5, naka-online ay 6. Yung non-fiction naman niya, under pa rin dun kay June, ay 4 yung paper, tapos 2 naman yung online. Yung magazines naman niya is 1 yung paper, and 3 yung online. Okay? So, pareho lang din kay July and August. So, mga matrix yun. So, meron tayong 3 matrices na given. So, solution. Paano ginawa? Pag-add lang natin kasi pinapaanap lang naman yung total number na binabasa ng reader. Okay? Kaya napansin nyo, yung unang matrix natin, ito yon. Okay? 5, 6, 4, 2, 1, 3. Sumunod naman ito. Okay? So, pag-add lang natin yung kada element, parang kanina lang. So, yan. So, ang lalabas dito guys, pag nag-add natin ay, syempre, meron siyang tatlong row at saka dalawang column. Bakit? Kasi yung format ng mga pinag-add natin, ganun yung niya, yung setup ng matrix niya. Kaya ganun din yung lumabas. Okay? So, magkakaroon tayo ng conclusion. He reads 9 paper fiction books. Kasi 'di ba, yung first column ay book siya. Okay? Paper. Under ng yung first row naman kanina ay fiction siya. Kaya 9. 9 paper fiction books. Tapos yung 30 naman, under naman siya ng online, tapos under din siya ng row. Okay? So, ganoon lang guys. Madali lang, di ba, yung addition. Ito lang ba? So, number 2. So, the bookshop of a particular school has 12 dozen chemistry books. So, ito naman, meron daw isang bookshop na may mga books. Okay? Kaya napansin nyo, yung 12 dozen chemistry books, 5 dozen physics books, 11 dozen economics books, nilagay natin dito as a vector matrix, a row vector matrix. Kaya nakita nyo, 12, 5, and 11. Ngayon, bakit meron 12? Bakit may 12 sa labas? Kasi sabi, dozen. Okay? So, kada isa na yun, guys, na-times natin siya sa 12 kasi isang dosena daw. Okay? Kada isa. Kaya mayroon siyang constant na 12 sa labas. So, ngayon, nagkaroon tayo ng, multiply pa sa kanya, yung column vector na ito. Itong 50, kasi $50 daw yung presyo. $60 and $30 respectively. Nung chemistry, okay? Nung physics, and nung economics books. So, nagkaroon nga tayo dito ng pag-i-multiply natin. So, first, i-multiply muna natin yung row, okay? Yung row vector, row matrix vector, doon kay column matrix vector. Isa-isa, kaya naging 12 times 50 plus 5 times 60 plus 11 times 30. Okay? So, yun muna yung gagawin natin. Multiplication muna, okay? Nung mga vectors. Then, multiply, then add. Tapos, pag isang value, then i-multiply nyo na siya sa 12. So, the bookshop will receive, $14,760 from the sale of these books. So, ayun, na-compute natin yung sale. Okay? Yung kita nung bookshop doon sa mga books, sa mga given books. Okay? And prices of those books. Okay. Naintindihan ba, guys? Mukhang wala nagtatanong sa inyo, aral nyo na to. No? Kasi naka-post naman eh. Diba? Dapat download yun na agad pag naka-post. Okay? So, in a June, number 3, problem. In a June shop, A, B, and C received 5, 10, and 5 deliveries respectively. So, dito daw, sa isang shop daw, nakakuha daw siya ng mga deliveries, 15 deliveries, 10 deliveries. Okay? So, dito, by using matrix multiplication, find the total number 5 kg. So, hanapin daw natin yung total number ng mga 5 kg, 10 kg, and 15 kg ng bags doon sa mga deliveries na yon. Okay? Kaya napansin nyo guys, yung mga number of deliveries, isa siyang vector. Ayan, 15, 10, tsaka 5. Okay? Samantala itong 50, 130, hanggang 70, hindi siya binigay sa problem pero nasa solution. So, more likely, given din ito. Okay? So, halimbawa sa 5 kg, merong mga 50, okay? 50 bags, 100 bags, 30 bags. Tapos under naman kay 10 kg, merong 60, 150, ganun yan guys. Ayun yung ibig sabihin niya. So dito, i-multiply lang natin yung row vector na ito na 15, 10, and 5. Dito sa given na square siya guys, na square matrix kasi pareho yung row niya and column. So paano ba tayo mag-multiply ng matrices? Diba? Yun nga, kada isa. Okay? Isang row muna, tapos yung column ng pangalawa. Okay? Kaya napansin nyo, inaisa-isa natin. Yung unang column ay ito. So, 15 times 50, 50 times 15, tapos plus 60 times 10, plus 80 times 5. So, inuuna muna natin yung column ng pangalawang given na matrix pag mag-multiplication tayo. Gets ba? Tapos ganoon din sa iba. Column muna. So, yung pangalawang column naman, sumunod yung pangatlong column. Okay? So, ayun. I-multiply, din ipa-plus lang natin kada isa. So, nagkaroon na tayo ng 1,210 para kay 5 kg. 4,000 naman kay 10 kg na bags. Ibig sabihin ng mga ito, mga bags.
Sir, excuse po.
Okay?
Sir.
Anong tanong? Yes,
Di ba
anong
po
tanong?
yung 60 times 10 is equals to 600? Ba't po 60 lang yung nakalagay doon?
Okay, dapat 600 yon. Ayun, so very good, napansin mo yon. Okay, so typo lang yan guys. So i-correct nyo na lang, so 600 yon. So 750 times, i-plus natin, plus 600. Okay, so magkakaroon ka ng 150. Plus 4 is, 1,750. Tama ba? So ito dapat ay 1,750. Okay? So, mali lang yung na-typo dito. Okay? Pero nagets niyo yung process, guys. Nagets niyo yung process nung multiplication ng matrices. So, sa una, row muna, sunod column. Okay? Kung ano yung mauna, dun, i-consider mo sa kanya yung row niya. Tapos yung pangalawa naman, per column. Okay? So, next naman, dito tayo sa transposition. So, we obtain the transpose of a matrix by writing its rows and columns. So, yung transposition, guys, ba, pinahanap sa inyo yung transpose ng matrix, gagawin lang natin yung rows niya sa columns niya. Okay? So, equivalently, it's columns as rows. So, or vice versa. So, this also applies to the transpose of vectors. Okay? Kahit sa mga vectors, pwede rin natin siyang i-transpose. Thus, a row vector becomes a column vector. So, pag meron tayong row vector, pag sinabi, find the transpose of a row vector, ang kakalabasin nun ay column vector and vice versa na yun. So, in addition, for a square matrices, we can also reflect the elements along the main diagonal. So, sa mga square matrices, consider natin ngayon yung diagonal niya. Okay? So, interchange entries that are symmetrically positioned with respect to main diagonal to obtain the transpose. Okay? Pag square matrices, guys, kailangan symmetrical siya. Symmetric yung pagtatranspose natin sa row by column. Okay? So, magkakaroon tayo ng example dito. Ayan, ito daw yung matrix A. So, transposition of matrices and vectors. Tatranspose natin siya. Kaya napansin nyo, ayan yung sign niya, guys. A, tapos raised to T. Kumbaga, transpose ng A. So, yung rows niya, pansin nyo, ginawa lang columns. Okay? Tapos, dito naman, kasi yung una kasi, guys, hindi siya square matrix. So, punta tayo sa may square matrix. Dito, guys, yung pangalawa, a little more compactly, we can write. So, hindi pa rin siya square matrix, no? Dito, maging square matrix na siya. Makikita nyo yung gagawin dito. So, dito, nakita nyo, yung row ay naging column. Okay? Tapos, dito naman sa square matrix, kapag transpose natin siya, mapapansin nyo, guys, na yung diagonal niya ay ganun pa rin. Okay? Magre-remain the same pa rin yung diagonal niya pag square matrix siya. Okay? So, pansin nyo ba na gano'n? So, furthermore, the transpose 6 to 3 of the row vector becomes, of the row vector 6 to 3 is the column vector. So, naging column vector na siya. Okay? Kasi row vector, naging column vector. Then, conversely, gano'n din. Kapag pag column, naging row vector na siya. So, post-test agad. Multiplication, addition, and transposition of matrices and vectors. So, dito ang gagawin nyo is mag-multiplication, addition, tsaka transposition. So, madali lang, multiply lang, addition, depende doon sa given. Kasi, halimbawa, dito sa number, itong 11. So, dito kayo magsisimula sa 11. So, dito, showing all intermediate results, calculating the following expressions or give reasons why they are identified. So dito, ika-calculate nyo lang. Halimbawa, kay AB, ibig sabihin, multiply nyo lang si matrix A, yung given dito, kay matrix B. Samantala naman, yung sumunod niya, multiply mo si matrix A doon sa transpose ni matrix B. So, itatranspose mo muna si matrix B, saka mo i-multiply kay matrix A. Okay? Kay 12, ayun, i-multiply mo si matrix A kay transpose ni matrix A. Okay? So, transpose muna bago multiplication. Tapos, ano to? Squared. Okay? So, pag mag-i-squared kayo, sabihin nun, i-multiply mo yung matrix sa sarili niya. Okay? So, susulat nyo lang yung magkaparehong matrix. Si matrix A, parehong matrix A. Then, susundan nyo yung row multiplied by column. Okay? So, ganun lang yung pag-i-squared nun. Okay ba, guys? Tapos sa 14, napansin nyo, ayan, nagkaroon na dito na ngayon ng subtraction. Okay? Sa subtract nyo, kada isa yon. Ayun, so dito, pagkatapos mo mag-subtract, subtract mo si 3 times matrix A, subtract mo siya kay 2 times matrix B. Pagkatapos mo i-subtract, yung lalabas na matrix, itatranspose mo ngayon. Kaya siya mayroong T, raised to T sa taas. Okay? So, maging aware kayo dun sa mga symbols ng raised to T. Ibig sabihin yun, transpose. Okay? Then dito, sa huli, so kada number, guys, may mga ano siya, may mga, kasi nakapansin nyo, they are separated by commas. So, yun yung gagawin nyo. Yung pinakauli dito sa 14, bakit siya small letter A? Dapat, meron kasi siyang given na small letter A. Tama lang. Ayun guys, so, ito yung A mo. Ibig sabihin ng small letter A, siya itong given na row vector. Okay, so huwag kayong makumpis doon, kasi may big letter A tayo, tapos may small letter A. Okay, so itatranspose mo lang din ito. So, madali lang siya guys, no, yung post-test. Kaya susunod nyo na kasi ay yung module 2 na. Okay? Siguro next meeting, tapusin natin, kahit itong tapusin yung module 2, tsaka module 3 pagsasabayin natin. Okay? Yung sana kung kakayanin. Pero kung hindi, since 9 hours naman tayo dito, pwede na pa naman tayo sa pangatlong meeting natin tapos yung module 3. Okay? Kasi 9 hours kasi ito guys eh. Kada meeting natin is 3 hours, 3 hours. Okay? Since once a week tayo nag-meet, 3 hours, 3 hours yung kada meeting natin. And since EOL kayo, 1 hour nga lang. Okay? So, maliwanag ba yung post-test? Madali lang siya. Ipa-plus lang. Mag-addition lang. Subtraction, multiplication, and transpose. Okay? May tanong ba sa post-test? Ipopost ko na lang siya sa Google Classroom natin. Okay? So, 30 ngayon nandito. Meron pang nag-join. Isisend ko na lang yung replay ng recording na ito sa ating group chat. Okay? So, ipopost ko na lang sa classroom natin na doon nyo na lang i-attach yung answer nyo para doon sa post-test number 1. Okay, may tanong ba? May klase ako.
Okay, sir. Thank you.
Anong tanong? Yes? Tanong na.
Paano po yung may mga kasamang number?
Saan yung may kasamang number? Ayun, pag may kasamang number, sige, pag may kasamang number, imumultiply mo lang siya ng number na yun. Halimbawa, 3A. Ibig sabihin lang, imumultiply mo yung kada element ng number 3. Kada isa yun imumultiply mo ng 3. Bago ka mag-perform ng sumunod na operation. Okay? O dun sa mga late na dumating, panoorin nyo na lang reply ha. May reply naman ito, recorded ito. Ilalagay ko sa ating group chat. Okay? Then kung may tanong kayo, feel free lang to PM me o kaya sa group chat. Okay? Sasagutin ko pag daw busy. Okay? Sige, kung lahat ba nakapag-attendance?
Sir, Ben Peter.
Susulat na lang po ba yan, sir? Sa papel.
Papel na lang, tapos picturean nyo lang ulit ng nababasa para ma-checkan ko. Okay? So, kung wala ng tanong, o may tanong pa kayo, mamaya na lang, PM nyo na lang sa akin. Okay, may klase pa ako ngayong 4. Sige, maraming salamat sa inyong pagdalo. Dapat naka-attendance kayo, ha? Sige, ingat kayo. Bye-bye.
Thank you, sir.
Thank you po, sir. Thank you po.